So let's go through more of these mechanics and semantics around interfaces and collections. And we're going to take a look at another piece of code here. So this time we're going to be using the printer interface with one act of behavior, print. That's on line 11. And then on line 16 we have our concrete type user and implementing the printer interface using value semantics. And now remember what that means. When we use value semantics, that means that we can store both values and addresses inside that interface. If we're using our pointer semantics, we can only share those values inside the interface. So we can do both here. Now, on line 28, we go ahead and we construct our user value. Let's do that on the board real quick. On line 28, we're going to construct that user value. There it is. User, it's going to have Bill in it. There it is. And then on line 32, I'm going to construct a collection. This isn't a collection of concrete data based on what it is. It's a collection of interface types based on what it does. I'm one interface type printer. So now we're going to have a collection of data, not based on what it is, but based on what it does. Remember, decoupling is based on behavior. And we could see that we're doing the construction of this collection of type printer on line 32. And we're storing during the construction two of those user values there. So when we're done with this, what we're going to end up is with our slice, length of 2, capacity of 2. And the backing array is going to be these two interface values. There they are right there, right? Two interface values. But if we look on line 35, remember we always got to know what semantic is at play. And that's going to say that we're using our value semantics are at play. We're going to be saying that we're storing a value of type user, and we're making a copy. We're making a copy of that original user value. So index 0 is leveraging the value semantics. And on line 38, you can see we're taking the address of u. We're going to be leveraging our pointer semantics. There they are. There's the original u. Again, we either have those values or those pointers. And this is a collection based on not what the data is, but based on what the data does. Any data, any value, or any pointer that implements that printer interface can be stored in this collection. Now, if we scroll down a little bit more in this code, you'll see two things. On line 42, we're changing this data out to now be Bill changed. And the first question I'm going to ask you is who's going to see this change, right? The only interface here, the only index in our collection that will see the change is the one using pointer semantics. This is operating on its own copy. So now we get to line 46, and we're going to be ranging over this collection. Anytime we start ranging over the collection, we've got to ask, should we be using the value semantic or pointer semantic form of the for range? Well, I'm using the value semantic form of the for range. Why? Let's go through the questioning. What is entities? It's a collection. What is it a collection of? Printer. What is a printer? It's an interface. What is an interface? Well, it's a reference type. We use value semantics for our reference types. We're just going to walk down this line of questioning all the time. That now means that we're using the right for range for this. And on the very first iteration, what happens? Well, E is its own copy, right? E is its own copy of every one of these. So this we're going to get is index 0 first, which means that E is going to be also pointing to our copy. And now when we call print against E, we're going to be just seeing Bill. On the next iteration, what happens with E? Well, E now becomes a copy of index 1, which is going to say I'm a pointer of type user, and I point here. And in that case, what we're going to see is the change. And again, we know what this behavior is going to look like because we know the data semantics that are at play on this collection. So now what we've seen is that if we want to create a collection of different concrete data, we've got to do it not based on what it is, but always based on what it does.